This conference will now be recorded.
Hi, everyone. This is Yuming. So I'm a thermal engineer here at Facebook. Together with me, Michael from Facebook will be also in this video to talk to you about the future Inference Accelerator module form factor. We also have Hao on the line who can actually answer the questions for you guys. And he's an electrical engineer. So today, for the overview section, we are going to talk about the M.2 and the dual M.2 form factor. This is our current design on Yosemite V2 platform and Yosemite V3 platform. We will also talk about the requirements and why we are solving this issue. And basically, Michael will give us an evaluation on YV3 to see what are the options are available. E1a, Pisa, Chem, and PE, CFF form factor. The pros and cons for each of them. In the end, we wanted to encourage everybody to contact with us if you see any opportunities that we can collaborate together to find a best path moving forward. What is M.2 and dual M.2? As shown in the last OCP summit, Facebook are also utilizing the standard M.2 form factor for our accelerator use cases. We also have an embedded heatsink, so make it easier to integrate into the system. This is a PCIe by 4 form factor. Similarly, we have a dual M.2 form factor. It's very similar to M.2. It's just looking like two of the M.2s combining together. The form factor is slightly bigger than 2 times the M.2. It's 46 by 110 millimeter, PCIe by 8. We also have a similar embedded heatsink. Let's look at how we actually use these form factors into our current platform. As you can see on the left-hand side picture, this card is called Glacier Point V2. This is our first carrier card in Yosemite V2 platform to carry all those accelerator cards. As you can see in the picture, this is definitely a shadowing configuration, meaning the dual M.2 or M.2s are shadowing by each other. This will have some temperature variance because one card is preheated by the other. However, in order to improve this, we have the current new generation of platform, Yosemite V3, as shown on the right-hand side picture. This is a 2OU configuration. That's meaning to give more space for us to place more accelerator cards into the system. We also have a dedicated NICs to increase the bandwidth. And as you can see, this is a non-shadow configuration. So basically, we'll have like better temperature distribution among the 6 of them. Let's look into the data in greater details about thermal comparison. The major difference between Yosemite V2 and Yosemite V3 from an accelerator placement perspective is one is shadow and the other one is non-shadow. So based on the data we have, the non-shadow configuration are definitely more beneficial to us because it have more uniform temperature distribution. And compared to the shadow configuration, it also have less pressure drop, meaning the fan power in order to cool these modules are slightly lower compared to the previous generation. Also, since we are not having a wide range of temperature variance, the potential power leakage for this configuration will be also less, meaning we will have an increased performance per watt. With that, I wanted to hand it over to Michael to talk about what is the problem and what are the proposal solutions we are thinking of.
Thank you, Yuming. So my name is Michael Haken, and I'm a mechanical engineer at Facebook. So as Yuming mentioned, we're going to talk about the future Inference Accelerator requirements. So we have 5 requirements listed here in no particular order. First, we'd like to have a standard form factor for better ecosystem support. Second, we'd like to have a high module density in our server platform. Our previous generation had 6 devices, so in our next generation, we'd like to have at least 6 or possibly even greater. Third, we'd like to have some flexibilities to support a mixture of both storage and Asic devices. Fourth, we'd like to support the high-speed IOs, PCIe Gen 5. And then finally, we'd like to have power and thermal support for ASICs up to 30 watt ASIC TDP. The problem statement we have here is that the M.2 and dual M.2 form factors are not great candidates because they don't satisfy all of the requirements above. So in the next slide, what we're going to see is 3 form factors that we've evaluated on our next generation system, Yosemite v3. For more information on the Yosemite v3 form factor and what that platform looks like, you can look at our other talks in this server track. Firstly, we have the E1a proposal. The E1a is very similar to the E1s. However, it's about 20 millimeters wider. The E1s is 33.75 millimeters in PCB width, and the E1a is 53.75. We do this to allow for more component placement around this Asic module, as well as better thermal performance for this module. The picture you can see in the bottom left is the Yosemite V3 blade module. In this case, we would have 6 devices per CPU, which is meeting our minimum requirement. And we also have some flexibility to support both the E1s and E1a in both of these slots, meaning we could support the flexibility that we wanted. We also determined that to support a minimum amount of airflow impact, we'd like to go with an orthogonal connector. However, we understand that there is a SI impact to this ortho connector, and we're actively investigating this further. Next, we can look at the Pisa Chem form factor. This is a much more common form factor used in the industry, and for this use case, we'd be targeting the Pisa half height, half length single slot card, or possibly even the double slot card. Depending on whether we use a single or double slot, we could either put 1 or 2 ASICs on this card, and that could allow us to get up to 6 ASICs per server, which does meet our requirement. There's also a possibility for supporting increased power and basically improved thermals for this module if we do go with a double slot. It could be PCIe Gen 4 supported, and we don't currently see a path forward to support flexibility between ASICs and storage media in this. All right, in the next slide, what we'll look at is the PECFF form factor. So PECFF is very similar to PCIe Chem. There is some distinct differences. The first of which is the connector is actually changed to use the SFF 1002 connector. This connector has a tighter pitch and better SI performance. When you go down from a 1 millimeter pitch to 0.6 millimeter, you can actually save a significant amount of card edge space, meaning traces that go to and from this connector can be shorter, just based on the different pitch. This would be a chassis compatible based between PCIe and PCIe PECFF. And also the PECFF does come with some added benefits in terms of allowing for module to module cables, as well as some other great flexibility. So in the next slide, we'll look at a comparison for each of these form factors. Starting with dual M.2, you can see that we don't have all of our requirements met, but our PCIe speeds at Gen 4 looks questionable with our next generation server platform. We see that the losses are quite high, and we also have issues with the thermal performance. EDSFF E1a looks fairly good for flexibility in terms of supporting both ASICs and storage media. It does perform well at PCIe Gen 5. However, there is some open questions we have about what the losses look like if we use our ortho connector that is better for thermal. PCIe Chem form factor, we don't see a path forward for the ASIC to storage flexibility, as I previously mentioned, but it does have very good PCIe Gen 5 support and also pretty good losses there. We do see a potential to support the 30 watt ASIC TDP in a good way with the dual slot PCIe Chem. And if we go over to PECFF, you can see it's very similar, but we actually have some added improvements around the loss associated with a different connector. Next, I'm going to hand it back over to Yiming, and we're going to look at the impact of the ASIC die size.
Thank you, Michael. As Michael suggested in the overview section, Facebook are still investigating on what is the best option for the industry and for ourselves. But despite of the form factors, there is still another factor that is playing a big impact towards the thermal for the ASIC cooling. That is the package and die. As shown in the chart below, if we increase the ASIC die size from 15 by 15 to 20 by 20, we can actually see a 13% temperature drop for the Asic module. If we go even further, we will see a similar trend for the drop of the temperature. So the understanding of the package and die size is very critical to the form factor selection. And we are looking forward to collaborate with the industry to see what is the best path moving forward. Call into action. Feedbacks and comments are highly appreciated. We do want to gather the information and also the comments from the industry so we can collaborate and find the best solution together. If you wanted to contact with us, don't hesitate to send emails to the below mailing list. And with that, we wanted to open the Q&A sections to answer any questions you guys might have. Thank you.
Thank you.
Hello, I do saw a question for me. So the question is, hi, Yumin, are you here considering local cooling for Asic or cooling valve system fans? So actually for this configuration, we are here looking into system fans to actually cool the system. We do not have a current plan to have the Asic to have active fans on itself. So the question is, we are still relying on the system fans to actually get the heat away from the Asic.
Yeah, I will address the question saying like on slide 5, you show a different orientation of the dual M.2 card. Is this correct? Yes, like in the Yosemite V2 and the Yosemite V3, we have different orientations.
I see a question from Chris about, can we plug E1a and E1s into the same mechanical panel? Yes, there is plans to support this. However, we're still working out the details. As the E1s is smaller, we would need some adapter to make that work. In terms of electrical compatibility between E1a and E1s options, both would use PCIe by 4 or PCIe by 8, and we have an ortho connector for SFF 1002 that could receive both a smaller card or the larger card, similar to how PCIe cards can receive either.
Hi, this is Hao. Just follow up with Bill's question. Or maybe Yumin, you can talk. Yeah.
All right, thanks, Hao. Yeah, so Bill, you have a question on things on the dual M.2s. It needs to change the orientation. Yes, this is correct. So on the previous generation Yosemite V2, we do have the fins like on the shorter direction. And however, for Yosemite V3, we change the orientation, so the fin direction also needs to be changed accordingly. And I see another question from Jayati. What are the factors other than thermal for Asic die size consideration? So I can answer part of it, and I'll ask Michael to add more over here. So there are several other things we need to consider. The first one is like definitely the cost. Like usually higher die size definitely also like have implication on the cost perspective. And the second is like how we actually package everything together. So that's another thing that might contribute over here. So we did, like, definitely Asic die size bigger is better for thermal, but there are other trade-offs that we need to take consideration as well.
Yeah, I'd like to add a little bit more flavor to JRT's question. So in the end, the Asic die size will be application driven, right? In the end, like depends on different accelerator applications. People have different requirements on the Asic die. So in the end, the form factor need to consider all different applications to accommodate it to a unified form factor. I think that's the biggest challenges for us to define accelerator module form factor, while like the Asic die size will be driven from the real workload side.
And I will take the other question from Peter. The question is, what power dissipation do you expect roughly for the E1a form factor? So currently, we did some preliminary analysis. The E1a form factor, the heat sink size are not very a lot compared to the current dual M.2. So we are thinking the E1a might be slightly, the power consumption we can actually take could be very similar to the dual M.2 currently. And the problem is like the dual M.2 currently cannot support PCIe Gen 5, but we are thinking E1a maybe. So I don't think like E1a form factor, just from the form factor itself, will have anything different compared to dual M.2, but it does have other benefits and other constraints as well. So the quick one is like the power consumption we are now targeting is around like 20 to 25 watts. For the exact one, I think it also kind of correlates back to the die size of the Asic.
There is a question from Jamal about the overcoming signal integrity limitations of M.2 connector. I think in the slides we mentioned so far the M.2 connector is just capable of supporting Gen 4, and definitely like we want to move together with the commodity to have a new, more like advanced solution to support Gen 5. I'm not sure like how much effort it's needed to overcome the limitation of the M.2. From this point of view, like we want to hear from the industry to see what's the trend we will go to. Like in the end, like we don't want to reinvent the whole commodity. We want to follow the mainstream.
All right, it seems that we don't have further questions from the audience. So thank you everyone for your attention, and we really appreciate all the feedback you gave us.
Thank you, bye.